Okay. Yeah. In first unit, under periodic properties, under the subheading electronegativity, right? There's a portion called, right? There's a portion factors affecting electronegativity. I didn't explain there, right? In that, I didn't explain these things in unit 1 because it belongs to unit 2, right? Okay. Factors affecting electronegativity, right? Okay. Right? Okay. There are 4 factors, or sometimes 5, right? Are factors which affect electronegativity, right? Okay. Especially, you should notice the chemical environment around the atom, right? Chemical environment around the atom affects electronegativity, right? Okay. So there are 5 factors. I have given 5 or 4. Okay, 4 factors. Sometimes 5. We'll study 5, right? First, hybridization type that affects electronegativity primarily. Initially, you should see hybridization type, right? Then, if the hybridization type is same, then you should see go for charge. If charge is also same, then oxidation state. If it is same, then finally nature of other atoms to which the atom is bonded. Right? Now the fourth one size. That I mentioned because its size is considered only for ions. Right? Only for ions. Monoatomic ions like Na plus K plus, which has high electronegativity. You should see what size because charges are same. Right? Okay. Let's see. So fourth one is only for ions, monoatomic ions, right? Right? Okay. So initially hybridization type O S character, right? Okay. Higher the S character, right? Higher the S character, greater is the electronegativity, right? For example, CH. Okay, actually, we have discussed this in unit 2 in hybridization. CH4. Okay, let's take C2H6 and C2H4 and C2H2. Which carbon? This one or this one or this one? Which carbon has higher electronegativity? Which carbon has higher electronegativity? What's the hybridization type? sp3, sp2, sp. Right? Hybridization type. Right? So S character, S character, 25%, 33.33%, approximately 33%, right? And here 50%. So which carbon has higher electronegativity? The carbon in C2H2, right? Higher the S character, higher is the electronegativity. Why? When the S character increases, what will happen? You know which orbital, S orbital or P orbital will be closer to nucleus? S, right? Okay, electronegativity is what? Ability to attract one pair. When it will be higher? When that ability will be higher? The electrons are closer to the nucleus. Right? This electron pair is very much closer to the electron of carbon. So when the S character increases, the bond length will be short. Bond length will become shorter. Okay, bond length will become shorter. So the attraction will be higher. Right? Okay, we have discussed this earlier. Okay, so this is the principal and primary factor. Right? If several species are given to compare the electronegativity, initially you should look for what? Hybridization type or S character. Right? Okay. Right. So under that, write what I am saying. Okay, write what I am saying. Hybridization type or S character. I have given one sentence. What's that? Higher the S character, greater is the electronegativity. Right? Okay. So under that, write this. Quickly. If you can, there's no way. Try to write there. First page. No. I'm writing one more examples. One more example. It's your homework. Nitrate NO2 plus NH3. Right? Arrange these in the order of, in the increasing order of or decreasing order, anything, right? In electricity, electronegativity. You can write it on next page, right? It's your homework. Nitrate NO2 plus ammonia. It's nitrate. NO2 plus means it's nitronium ion, ammonia, right? Okay. Okay. Next, second one. What? Charge. Let's check. Let's have NH2 minus NH3. NH2 minus NH3 NH4 plus. Which nitrogen is highly electronegative? Most electronegative, this nitrogen. Right? This is the order. Why? Why? The reason is what? Right? I'm going to draw the I'm going to draw the Lewis structure of these three species. Okay. What's the charge on nitrogen? -1. Charge on this nitrogen? 0. Charge on this nitrogen? +1. So which nitrogen has most which nitrogen is most electronegative? This nitrogen. Right? Okay. minus 1 charge, here 0 plus 1. Okay, right? Yeah, note this. You can check it, check at home. What? Hybridization of S character is same for all, right? What's hybridization type? Hybridization type sp3, sp3 and sp3. So you can't compare this by hybridization type, right? Okay, quickly. Right? Okay, next. What's the third one? Oxidation state. Okay, oxidation state. Sulfur in H2 is sulfur in SO3 2 minus. Sulfur in SO4 2 minus. If we draw the Lewis structure, right? Okay. Type of hybridization same. sp3, sp3, sp3. So you can't compare this by hybridization. Charge same 0. So charge of sulfur 0, 0, 0. And oxidation state. Oxidation state. Oxidation state of this sulfur is -2. This sulfur +4. +6. When the oxidation state increases, electronegativity also increases. Have we studied oxidation state? No. It's okay. We'll study in next class. Right? We are going to start chemical calculation, third unit. Third unit start oxidation state. That's the first part. So for the day, you don't have to worry. That is all, right? Okay, right. For the oxidation state and charge are almost same concept. Charge and oxidation states are almost same concept. There's a little bit difference that we'll study later, right? Right? Okay. Next, size. When the size increases, electronegativity. What happened to electronegativity? For example, Na plus K plus Hybridization type is not considered because it's an ion, monoatomic ion, right? And then oxidation state, charge same, oxidation state same, right? Okay, size, right? Small size, large size. So which one is most electronegative? Na plus is most electronegative. Always, when the size decreases, electronegativity increases, right? Size decreases because electron pair pulling ability increases with decreasing size, right? Okay. Okay, note it down. That's all. And put that point inside a bracket. Put the whole point, right? Whole fourth point, right? Fourth point in a size, fourth factor. Completely put a bracket, right? Because it's separate, right? And last one. The charge is used only for ions, monoatomic ions. Got it? Okay. So cut it. Next. Finally, nature of what? Nature of other atoms to which the atom is bonded. Right? Okay. For example, CF4. And CCl4. CH4. Right? CF4, CCl4, CH4. Which carbon is most electronegative? Which carbon? Only carbon. This is the order. Why? You should consider the electronegativity of other atoms, terminal atoms, right? Because central atom is same, right? And consider other factors. Hybridization type is same. Ola sp3 hybridized, same. And charge 0. Oxidation state is studied later. Oxidation state we will study later. +4 also same. So nature of other atom. Here carbon is connected to attached to fluorine. They are fluorine, right? You know, fluorine is electronegative. Chlorine is also electronegative compared to carbon. Compared to carbon, both are electronegative. But which one is most electronegative? Fluorine is most electronegative. Right? So which you are able to see fluorine is delta minus, carbon delta plus. So which carbon? Carbon in CF4 or carbon in CCl4 will get more delta plus? This carbon or this carbon? This carbon. Because fluorine higher electronegativity, fluorine has very high electronegativity, so it pulls the electron pair very much compared to this fluorine, right? So delta plus charge will be higher for fluorine. Delta plus, when the delta plus O plus, we have already seen that what? When the charge positive charge increases, electronegativity increases. Oxidation state increases, electronegativity increases, like this here. Positive charge increases, positive charge increases, the electron pairs are what? Negative charge. So electron pair attracting ability also increases. So got it? Okay. And write a small statement and then note it down. Quickly write the statement. First draw it. don't take much space. Lucky ready. Right? Okay. And then another right product side. And this, right? Right? Fluorine is more electronegative than chlorine. Fluorine is more electronegative than chlorine. Higher electronegativity of fluorine. Higher electronegativity of fluorine. Makes the carbon atom which is attached to 4 fluorine atoms, highly electropositive, compared to the carbon atom attached to 4 chlorine atom. Carbon atom attached to 4 chlorine atom. This makes the carbon attached to fluorine. To have a higher electronegativity. Okay, that's all.